So, hello everyone, thank you for coming. Today we're going to talk about Windows Phone 8 application security.
Hello everyone, my name is Dmitry Yevdokimov. I'm security researcher in ERP-Scan company. I'm specializing in SAP security and mobile security, iOS, Android, Windows Phone. And I solve tasks related to reverse engineering, fuzzing, exploit development, and other low-level stuff. Also, I Zero Nights conference co-organizer.
And my name is Andrei Chesovskih. I'm a software developer and I mainly focus on .NET platform. So let's have a brief overview of today's talk. First we will shortly introduce Windows Phone 8. Then we will discuss its security model, the main concepts of its security model. After that we will talk a little bit about system internals, how you can learn the system, so how you can understand how the system works and application works. And after that we will talk about applications, what Windows Phone application is, how it looks like, and finally we will talk about application security. So let's start. Windows Phone 8 is a new version of smartphone operating system from Microsoft. The previous version was version 7. Windows Phone 8 is based on the same core as Windows 8 and it has ARM architecture. Well, the talk about application security only makes sense when you have some significant number of applications and users. So how many of you have Windows Phone in your pockets? Well, it's quite the same situation. Total market share of Windows Phone is not so impressive, but it constantly grows, and I know that in some countries it's quite popular. For example, in Italy it has 14%, in Russia, for example, it has 8%. Well, analysts say that Windows Phone will have like 20% by 2015, but we personally doubt this estimate. We think that numbers like 10% or 15% are more likely. Now it's struggling with BlackBerry for third place, and maybe someday it will struggle with iPhone for second place. Well, Android remains number one. Of course, Windows Phone has its own application store. There are all kinds of applications from social networking to mobile banking. And it's important to mention that Microsoft is targeting Windows Phone 8 not only to consumer market but also to enterprise market. So they added some new features to this version to support enterprise needs. So now let's see what Windows Phone 8 offers us from the security point of view. Windows Phone 8 security model is based on several concepts. The first concept is chambers. Chambers are some kind of boundaries which allows or disallows applications to do certain things. So we have two chambers. The first one is called Trusted Computing Base. All kernel level software run in this chamber. And the second chamber is called Least Privilege Chamber. So every non-kernel level software run in this chamber. The main difference between these two chambers is that Trusted Computing Base has fixed permission set. Actually, it has full permission set. It can do anything on the device. And Least Privilege Chamber has dynamic permission set. This permission set is based on application capabilities. And when one is configured, application can go outside of these boundaries. It can do or access anything that is not allowed. So every application has its own chamber based on capabilities. Capability is some kind of a marker which tells operating system that application uses some certain functionality. It's actually the same model as permissions in Android. For example, if you have navigation app, it may use location and access to the internet. So application tells to operating system that I need location services capability and I need network access capability. And when user install this application, operating system read these capabilities, configure a chamber for it, and later if application will try to access, for example, media library, it will get an exception. There are actually three types of capabilities. There are capabilities that can be used by anyone, by any developer. There are capabilities that can be used that are accessible only for vendors, and there are a list of system capabilities. In Windows Phone 8, Microsoft added a lot of new capabilities. Some of them were added to support some new features like NFC or SD card, but most of them were added in order to configure every software, in order to configure every chamber for every software. We see that homebrew developers can use less than 30 capabilities, while system capabilities list contains more than 300 of them. Well, none of them might be actually used, but we can still feel the difference. For example, if I'm, as an ordinary developer, will try to use vendor or system capability, I won't be even install and test application on the device. So capabilities are declared in special manifest file. We'll talk about it a little bit later. The next concept is sandboxing. It's about isolation between applications and between application and operating system. There are several basic points we want to tell you. First, that a file system structure is hidden from applications, and all input-output operations are limited to local folder. Each application has its own local folder, and it cannot access local folders of other applications. And application communication is very limited as well. There are no rich IPC mechanisms like in Android. App-to-app communication is actually limited to two scenarios: file types associations and URI associations. So, every application can register that it can handle certain file types or certain URI schemes, and when another application will try to open a file of this type or will try to launch a link of this URI scheme, the first application will be launched. This communication is handled by operating system, so application don't know anything about each other. And what is more, when application handle files, it can access the original file. It can access the original file, it can only copy it to local folder. Local folder is kind of place where application stores its data. It's the same as in iOS or Android. It's previously known as isolated storage, but in this version of operating system, Microsoft renamed it to local folder. So every application can store its data in three ways. It can use setting storage, which keeps key value pairs. It can use file storage, which keeps files and directories, and also it can use database. Windows Phone 8 has embedded database, which is SQL Server Compact Edition.
Microsoft also takes steps to protect application content and to make application distribution and more secure. First of all binaries in Windows Phone 8 have a digital signature. Second, application file signed, they have some kind of checksum internals. If you change some content of application, you should also change that checksum or just remove it with checksum. Third, Windows Phone 8 uses certificate pinning when installing apps from the store. So a cell man-in-the-middle attack won't work. And finally, all ZAPS files from the store have a DRM key. In Digital Right Management System and Windows Phone 8 based on Microsoft PlayReady. On the slide, you can see Microsoft PlayReady architecture. When developer submits application, package server taking unprotected content and package it for distribution. After that, protected content copied to distribution server and the license for it copied to license server. Before a client can play back content, install application in our case. It must acquire a license from license server. You can download application from Windows Store on PC and then install this application from SD card. But you can't install application without internet because you need connection to license server, and you can install old version application because license server have only key for actual version. When Windows Phone 7 came out, all ZAPS files were just ordinary zip archive which you could open and view its content. Now format is different. ZAPS file contains a new file header, PlayReady header object, and encrypted zip archive. PlayReady header object is used by installer to locate and acquire a license, and application content encrypted with AAC algorithm. We got these details by examining operation system itself, and now we talk a little bit about how you learn Windows Phone 8 internals. As we said, Windows Phone 8 is based on Windows 8 Core. To see how much they're similar, we need to compare some core files, and guys from Interpedius group make it. They extracted files from the Windows Phone 8 emulator and compare NTDLL and NTS kernel files with their desktop version. You can see that they are almost similar, more than 99% for both files. Files from device should be compiled with Windows RT as they have ARM architecture, but in general we show us that basic layer of operation system is common between mobile and desktop platforms, and of course some bugs will be common too. Windows Phone emulator is a virtual machine, and it uses Windows Phone 8 Hyper-V image. This is a full image of operation system compiled as x86 architecture. You can mount this image and explore them. Emulator works in the same way as device. The main difference, input difference, is that you can't install application from the store. In Windows Phone 8, Microsoft introduced standardized the download bootloader requirements for OEM vendors. Now all ROMs one format called FFU, and the vendor are not allowed to decision their custom ROM formats. You can download some image for various devices from internet and mount with image mount tool and explore contents. Unfortunately, there is no public full unlock available these days for Windows Phone 8. Now let's see how we can learn something from system binaries files. Unfortunately, debug symbols not available, but we can use event tracing windows to restore information. I wrote a simple plugin for IDA Pro using IDA Python, which find a iterative writer function and then make back trace for R3 register. Oops. R3 register. R3 register store a function of current name, name of current function. If you want this script, I can share it. This is a static analysis, but we can dynamic analysis. Also, by default, developer can use a limited subset of Win32 API functions, but we can use all the techniques for calling an arbitrary function in Windows Phone 8. We make any load call from kernel-base.dll and then find a start address of DLL by mz signage and parse import table for get proc addresses and load library functions. And then we can call any function you want. This technique is what used in Windows RT. We check it for Windows Phone 8 and it also works. For example, you can read contents from Windows system folder.
So now let's move closer to applications. As we already mentioned, Windows Phone 8 is based on Windows 8 core, so it uses the same set of core components as desktop version. .NET Framework version was also updated, so now Windows Phone 8 uses a big .NET version called Core CLR. It's actually the same version of CLR that Silverlight application run. In Windows Phone 7, developers could only use managed code to create applications, but in Windows Phone 8, Microsoft introduced two big sets of APIs. The first one is called Windows Phone RT. It's a subset of WinRT, a new COM-based API, which is some kind of substitution for Win32 API, and also developers can use DirectX. And what is important, now developers can use native code to develop applications, but support of this native code is still limited. For example, you can create pure C++ application. You still have to use, for example, C# and XAML for creating UI. But still, you can consume these two APIs, and you can reference other native libraries. There are several kinds of applications. There are first-party applications. These are applications from Microsoft itself. There are second-party applications, which are IAM applications. So when you buy a new device, you already have some pre-installed apps. The most common are third-party apps. These are applications from the Windows Phone Store. And also you can develop and distribute applications without Windows Phone Store. For example, if you have special type of account, it's called company account or enterprise account, you can develop your own application and you can enroll it on the employees' devices. Also, if you have developer account, you can develop application and install it on your device to be able to test it. But for this, you will need to have developer unlock. It's important to mention that not all of these applications, developer application and OEM application does not have DRM protection. So we can explore them. We are able to open them and to explore them. Now let's see what Windows Phone application look like. So when you have Windows Phone application, you have a ZAP file, which is actually zip archive, which has all the content inside. So there are different file types. There are application assemblies in various formats, both managed and native. There are some resources like images or sounds, and there are also several manifest files. The most interesting is called WM app manifest. It contains all application-specific information like name, version, operating system version it supports. It also declares list of capabilities, the list of registered file types, URI schemes, and so on. Now let's talk about application security. So developers of every operating system try to make their system secure, and so that all applications will have some minimum level of security. But it's just the one part, and the other part is how developers protect their applications and how they mitigate the risks. One of the main threats for application is data that it passed outside. So in Windows Phone 8, Microsoft has added a lot of new features, and some of these features deal with the data that is passed outside. So this is the place where developers should be careful. We can divide all vulnerabilities into two groups. There are vulnerabilities that are connected to operating system. We can call them platform-specific vulnerabilities, but also there are common vulnerabilities, common for all operating system and for all applications. So we can call them platform-independent vulnerabilities. And this is interesting place for security researchers, for security auditors, and this is also the place where developers have to be careful. And now Dmitry will make a review of some common application issues and vulnerabilities in the context of Windows Phone and in comparison with iOS and Android.
Let's start from SD card. In Windows Phone 8, work with SD card is pretty strict. User can store only media, documents, and application. Application on device can perform only read operation and can only work those file types it has registered. SD card content is not encrypted as in Android. Big concern in mobile security is user privacy. Windows Phone application can get device ID, Windows Live Anonymous ID. This requires special capabilities. And need to get these identifiers in Windows Phone 8. Sorry. In Windows Phone 8, this identifies per publisher. This means that two applications from different publisher will get different identifiers. Also, application get basic device information, for example, device name, manufacturer, firmware, and version. Other things security auditors should pay attention to is location tracking. In Windows Phone 8 application, also able to track location in background. Maybe you know about incident with AVG antivirus, which was banned from the store because he was sending personal information, including local tracking about user. In Windows Phone 8 devices, internal storage can be encrypted, but it is limited to enterprise. Only if you can company account, company may turn on encryption. Plus, in some countries, this feature is not available due to law restriction. For example, Russia or China. So if you are a regular user, your data may not be protected. This requires application to encrypt sensitive data that they store or transfer it to the network. For example, both iOS and Android platforms have a keychain for storing encrypted data. But Windows Phone developer should use a special API to encrypt data before it will be stored. As I already mentioned previously, a big concern in mobile security. Application may process or store sensitive data, and this data should not leak. We know such more examples in other platforms, but Windows Phone is more secure in this question. For example, keyboard cache is isolated per application. In other systems, the situation is more worse. iOS and Android have more side channel for leak information. One of new feature in Windows Phone 8 is URI association. This is one attack vector. If code that process URI and its parameter is incorrect, a legal action may be executed. Also, it's not recommended to make any critical or security decision based on URI parameters. All input should be filtered. In iOS and Android, we see the same situation. Developer is fully responsible for handling URI. Now let's talk about cross-site scripting in Windows Phone. Windows Phone application can use web browser control for displaying and processing web content. Web browser control is based on Internet Explorer 10. By default, script execution is disabled. If you are an auditor, first things should you check is whether JavaScript is enabled. If so, check for input and output data. Directory traversal or path traversal is exploitation of insufficient validation of user-provided file names. If application somehow accept file path while user input or from the web server and do not filter it, we can read some information within local folder of application. There are several APIs that works with files. The old one from Windows Phone 7, the new one from Windows Phone 8 is storage folder class, plus several Win32 API function. This flow may seem obvious, but still some mobile application have it. This can be easily exploited with man-in-the-middle attack. XML is another security point. As you know, XML can contain two external entities which may be resolved during XML processing. Entities that contain data may to lead to information disclose or other system impact, for example, denial of services or remote code execution. Windows Phone 8 has a separate namespace for XML processing. By default, resolving external entities is disabled. It's good. But developer may use a custom XML resolver and write its own logic for processing external entities. This vulnerability is also simple to exploit with man-in-the-middle attack, so pay attention to custom XML resolver. Good old SQL injection, it's never die. In Windows Phone 8, developer can use database, so SQL injection is actual. Just like in iOS and Android, Windows Phone allows developer to use parameterized queries. Using parameters in SQL commands eliminates any threat of SQL injection. This also may seem simple, but still SQL injection in OWASP mobile top 10 list. This is my favorite topic, memory corruption bug. In Windows Phone 7, only OEM vendors, developers could use native development. Now all developers are allowed to use C++. Not secret that low-level work with memory is dangerous and may lead to memory corruption issue, for example, buffer overflow, format string, or use after free. To develop Windows Phone 8 application, developers have to use Visual Studio 2012. By default, all security-related compilation flags turned on. This is good, but still developers have to write robust code as these flags make exploitation more complex, but don't make it impossible. To compare with other platforms, we can say that its area Windows Phone is close to Android, while in iOS exploitation of such memory is very hard due to code signing.
So wrapping up, we discussed, we had an overview of Windows Phone 8 security model, and we consider it pretty secure, at least for now. We saw that Windows Phone 8 has a lot of new features, which may lead to new kinds of attacks. And what we noticed during this research is that API, all security-related API that are used by developers is more flexible than in iOS. It gives you more space, it gives developer more space to configure the things, but yet it's simple enough, so developers shouldn't miss something important, not like in Android. So we feel that this presentation may be useful for people who is already familiar with Android or iOS and want to get some knowledge on Windows Phone, on making assessment of Windows Phone applications. So thank you for your attention, and we are ready for your questions. No questions, really?
Thank you for your attention.
Let's grab some lunch.